Hi, welcome. Today we're going to talk about definite integrals. So definite integrals are what we've been talking about for a while, but I'm going to give you some formulas and then go through them and get some examples. It's just a sort of a do day, not a thinking about day. So recalling though, a definite integral is the signed area under the function y equals f of x, going from x equals a up to x equals b. So the first kind of formulas we're going to talk about are what happens when a and b kind of change. Well, the first thing is, if we're going from a to a, how much area is that? Well, think about a function. If I have a graph, and I want to talk about the area from A, starting at A and stopping at A, how much area is that? Well, the width is 0. And if you got 0 area, if you got 0 width, you're going to have 0 area. I sort of jumped the gun there. We have 0. Because you're not going anywhere. You're starting and stopping in the same place. There's nothing in there, just a straight line, and lines don't have area. On the other hand, suppose I go from A to B, and then I go from B to C. So I've got the area from A to B, and I add on the area from B to C. What do I have? I've got the entire area from A to C. These are useful. Now, suppose I switch the order of these two endpoints. So now I'm doing the area from B to A. So I'm starting here, ending there. How do I do this? Well, there's a way to do it. We can figure it out from this equation. If I make C in this one be an A, then whatever this one originally was, plus what I'm looking for, is the integral from A to A, which is 0. So this original one plus the switch has to be 0. So what that tells us is that whatever this is, it's equal to the opposite of the normal direction. So A to B gives us whatever this is, B to A gives us the negative of that. Why is it? Because there's a direction involved. We haven't really talked much about it, but this dx right here is a width, and as long as you're going this way, it's positive. But if we have to go that way, now we've got negative widths. Remember, it's signed area. There can be positives and negatives. It may seem a little funny, but these three will help us a lot. Now, some more formulas before we stop. Couple of just direct ones. If I've just got a constant, all I have is a rectangle, and the total area is just whatever that number is, 1 in this case, times the length. If I have an x, I've got a triangle. It turns out that the area of that triangle, well, if I'm going from A to B, it's more of a, well, what does it look like? It'll be a trapezoid. And the trapezoid area is there. Now, suppose I have two things in here. I can split it apart. The integral of f plus or minus g is going to be the integral of f plus or minus the integral of g, as long as they've got the same endpoints. If I've got a number in there, I can pull the number out. Remember these two properties. They have to do with what makes an operator linear, but we don't have to worry about that right now. And then one last one, it's called the comparison theorem. It's fairly sensible. If a function is smaller than another function over a certain interval, then the area underneath it is going to be less than the area under the other one. This can be useful for comparing things, hence it's called the comparison theorem. Sometimes you may not know what f is, but you know it's smaller than some other function that's easy to use. That's where this is used. But, on to some examples. I'm giving you some bits of information about two functions that we don't know. I know that the function from 1 to 2 is 3.9 area. Going from 2 to 5, it's 7.1 in area. And this other function g from 2 to 5 is going to be minus 1.4 area. Remember, it's signed area, so we can't have negatives. So my first question is, going from 1 to 5, what's the f of x dx? The next one, 2 to 5 of f of x minus g of x dx. Well, you can read these. Try them out. Okay, let's see. What about the first one? I want to go from 1 to 5. Well, one of the relationships we had earlier says it's from 1 to 2 plus from 2 to 5. So it's 3.9 plus 7.1, which is just 11. How about this one? 2 to 5 of this minus that. Well, that's the same as 2 to 5 of the first one. Minus 2 to 5 of the second one. So that's 7.1 minus 1.4. Be careful with that. And we get 8.5. The next one, I can pull this 8 out of here, and I get 8 times that 3.9. So what's that? 24 plus that 31.2. And the last one, from 5 to 2, is going to be the same as from 2 to 5, but with a minus sign. Hopefully, doing this is not so bad to you. And it makes sense. And then you can do some problems on your own. Until next time, this is Dr. Joe.